Lung volumes and capacities are measured clinically to assess a variety of pulmonary disorders, including asthma and emphysema. This video will define the terms and equations used for measuring respiratory volumes and capacities, demonstrate how to measure volumes and capacities using a handheld spirometer, and demonstrate how to predict vital capacity. A spirometer is an instrument used to measure respiratory volumes. This is a tracing from spirometry of a healthy young adult male. We'll use this tracing to discuss measurements and average respiratory volumes and capacities. The tidal volume, or TV, is the unforced volume of air inhaled or exhaled with each quiet, normal breath. The average volume for tidal volume under resting conditions is 500 milliliters, or ml. The inspiratory reserve volume, or IRV, is the volume of air that can be forcefully inhaled following a tidal inhalation. The average inspiratory reserve volume is 3,100 milliliters. The expiratory reserve volume, or ERV, is the volume of air that can be forcefully exhaled following a tidal exhalation. The average expiratory reserve volume is 1,200 milliliters. The residual volume, or RV, is the volume that remains in the lungs following a forced exhalation. The average residual volume is 1,200 milliliters. Inspiratory reserve, tidal, and expiratory reserve volumes can all change with exercise. On the other hand, residual volume doesn't change with activity, but may increase with age as lung elasticity decreases. Respiratory capacities are the sum of two or more lung volumes. The inspiratory capacity, or IC, is the maximum volume of air that can be inhaled in a single inhalation. Inspiratory capacity is the sum of the inspiratory reserve volume and the tidal volume, an average of 3,600 milliliters. The functional residual capacity, or FRC, is the amount of air that remains in the lungs when you exhale a tidal breath. The functional residual capacity is equal to the sum of the expiratory reserve volume and the residual volume, an average of 2,400 milliliters. The vital capacity, or VC, is the maximum amount of air that can be exhaled after a maximal inhalation. The vital capacity equals the sum of the tidal volume, inspiratory reserve volume, and the expiratory reserve volume, an average of 4,800 milliliters. The total lung capacity, or TLC, is the sum of all of the lung volumes, an average of 6,000 milliliters. Let's check your understanding. Refer to the text on the screen. Which of the choices is a correct expression? IC equals IRV plus TV, VC equals TLC plus RV, or FRC equals ERV plus TV. Recall that capacities are the sum of individual volumes. The inspiratory capacity is the sum of the inspiratory reserve and tidal volumes. Once you get used to the abbreviations, it will get easier. Most of our breathing is done under resting conditions, so let's return to tidal volume. We will be using a non-recording spirometer to demonstrate measuring volumes and capacities. To measure a tidal volume, the subject will inhale a normal breath and then exhale into the spirometer. The spirometer can measure only exhaled volumes and capacities. Subjects should not inhale using the apparatus. It's always best to take several readings and calculate an average volume. The minute respiratory volume, or MRV, is the amount of air exchanged with the environment in 1 minute, which equals the tidal volume multiplied by the number of respirations or breaths per minute. Let's check your understanding. During exercise, the MRV often increases to 20 liters, 4 times the MRV at rest. Which of the following do you think increases with exercise? Tidal volume or residual volume? Recall that the residual volume doesn't change with activity, but the tidal volume and number of breaths per minute can change. The expiratory reserve volume is measured by exhaling as much as possible into the spirometer after a normal, quiet exhalation. It's not necessary to blow forcefully, just evenly and completely. The spirometer can measure only exhaled air volumes, but we can measure the vital capacity and, from that, calculate the inspiratory reserve volume. The vital capacity is measured by inhaling as fully as possible prior to exhaling completely and evenly into the spirometer. Recall that vital capacity is the sum of inspiratory reserve, tidal, and expiratory reserve volumes. To calculate the inspiratory reserve volume, we rearrange the equation to see that inspiratory reserve volume is the same as the vital capacity minus the tidal and expiratory reserve volumes. Vital capacity is dependent upon age, height, and gender. Vital capacity decreases with age as muscles weaken and the lungs lose elasticity. Vital capacity increases with height because height affects the volume of the thoracic cavity and therefore how much the lungs can expand. We can predict a person's vital capacity based upon these variables. The equations for predicting vital capacity in liters are shown on the screen. H is height in centimeters, and A is age in years. Spirometry is a clinically significant tool. For example, spirometry could reveal a restrictive disorder such as tuberculosis if measured vital capacity is much lower than expected. Predict your vital capacity using the appropriate equation. As you head into the lab, think about the measurements you would expect from the spirometer and why vital capacity changes with age and exercise.